Ambika Tadke, Assistant Professor at ABP KBTCU in Nashik. Video on HCI model. Let's see what are the different HCI models. First is cognitive models. Cognitive models have a rather computational flavor. This reflects the way that computational analysis are often used in cognitive psychology. The presentation of the cognitive model is divided into three categories. First is hierarchical representation of the user's task and goal structure. Second is linguistic and grammatical models. And third is physical and device level models. This is cognitive models. The six cognitive categories are presented diagrammatically. First is information. Information specifies terminology, specific facts and means of dealing with. Specifies specific conventions, trends, sequences and classifications. Second is understanding. The meaning, translation, interpolation. Understanding is the meaning, translation, interpolation of instruction problems. Third is application. Use a concept in a new situation. Use of abstraction. Fourth category is investigation. Separates material into components, parts, so that its organization structure may be understood. Fifth is combination. Builds a structure from diverse elements put part together to form a whole with emphasis on creating new structure. Sixth is assessment. Make a judgment about value of ideas when we see the knowledge domain broken down in this way. It begins to make a little more sense to us. So these are the six categories of cognitive. The level of representation at variance from technique from models of high level goals and results of problem solving activities to description of motor level activities such as mouse clicks. Next model is goals and task hierarchy model. Many models make use of mental processing in which the user achieves goals by solving sub-goals in a divide and conquer fashion. Example, imagine we want to produce a report on sales of introductory HCI textbooks. To achieve this goal, we divide it into several sub-goals. Gathering the data together, producing the tables and histograms, and writing the descriptive material. Concentrating on the data gathering, we decide to split these into further subgoals. That is, find the names of all introductory HCI textbooks and then search the book sales database. The example can be laid out to expose the structure like produce a report, gather data, find book name, to do keyword search of names database, layout tables and histogram, write description. So goal and task hierarchy includes GOMS. GOMS describes goals, operations, methods and selections. So this diagram shows the cognition step, data into motivations, actions into principles, motivations into data and principles into actions. Decompose task goals into methods consisting of operations, need, data, actions and motives. Already we taken one example of HCI textbooks. Express as if then rules that determines what the user will do depending on their working memory content. Three examples of recent work that address some of these issues: parallel process using CPM GMS automated in Apex Epic. So GMS is a theory of cognitive talent involving human-computer tasks. It is based upon an information processing structure that assumes a number of different phases, example sensory store and working memory. This is the structure, or you can say the diagram of GMS model. So goals, methods, operators, then selection rules. So goals are something the user tries to do. Verb, example, delete word. Accomplished by methods, steps, like consisting of operators, like actions the use of or executes. Example, move left cursor. This is the goal, and press key operator. Okay, and selected by if then use. So basic actions, move to mouse. So this is the just example. We take the delete word. Okay, so goal is delete word. Operation methods, different steps methods are given, and goal is mouse left cursor, and action is perform press key. So this is the structure or model of GMS model. GMS is decided to human information processor model for human computer interaction that explain the user cognitive structure of on 4 components. GMS models compose methods that are used to achieve specific goals. First is goals. These are the user's goals. It is user goal with symbolic structure that describe a state of dealings users wants to be achieved, a set of possible methods by which it may be accomplished. Second is operators. Operator is the lowest level of analysis. They are the basic actions that the user must perform in order to use the system. They may affect the system. Example, press the start key, or only the user's mental state. Example, read the dialog box. There is still a degree of flexibility about the operators. We may take a command level, issues the select command, or be more primitive. First is move mouse to menu box. Second is press center mouse button. Act whose execution is necessary to change any aspect of the user mental state. Third is methods. Sequences of subgoals and operators that can accomplish a goal. As we can already noted that there are typically several ways in which a goal can be split into subgoals. For instance, in a certain window manager, a current selected window can be closed to an icon either by selecting the close option from a pop-up menu or by hitting the function key. In GMS, these two goals are referred to add methods. So we have close method and L7 method, that is function key. So this is the method. The form of method is like step 1 is start, step 2 is accomplish, up to step n, report goal accomplished. Fourth approach is selection. Rules are needed when a goal is attempted. There may be more than one process available to the user to complete it. From the methods will be used. This is typically depends both on the particularly user, on the state of the system, and the details about the goals. Example, a user Sam never uses the L7 method, except of one game blocks, where the mouse needs to be used in the game until the very moment the key is pressed. GMS capture this is a selection rules for SAM. User SAM rule 1 is use the close method unless another rule applies. Rule 2, if the application is blocked, use the L7 method. So the goal hierarchy describes GMS analysis are almost wholly below the level of the unit task defined earlier. A typical GMS analysis will therefore consist of a single high-level goals, which is then decomposed into sequence of unit tasks, all of which can be further decomposed down to the level of basic approaches. So this is GMS model. Method to accomplish move file. Step 1 is select icon file. Step 2 is drag icon destination. And step 3 is report goal completion. One of the most validated method in human-computer interaction is the GMS model. Assume expert user and well-defined task. There are various limitations to this technique. Example, task in a question must be usefully analyzed in terms on a procedural language. Depends on the skill behavior, not useful for ill-defined problem-solving exploration. Need to start with the list of top-level tasks. There are several different GMS variations which allow for different aspects of an interface to accurately study and predict. Already we seen the example goal, get. Goal is edit unit task, goal acquire the unit task, get next page, next task, and execute unit task. Cognitive complexity theoreticity, it is a parallel model which proceduralization of actions. With previous experiences, error behavior can be presented. Cognitive complexity is how well people perceive things. It has to do with how a person looks at event structures and how correctly an individual analyzes based on how complex. So next model is linguistic model. User interaction with computer often used in terms of language. Understanding the user behavior based on analysis of language between user and system. Cognitive structures, it represents two models. Problem space model. First is problem space model. It can be adapted of a machine in order to realize architecture of knowledge level system. It consists of a set of state operation which can be performed states. The second is interactive cognitive subsystem model, ICS model. It is most generalized cognitive architecture. ICS represents a model of perception. ICS has a holistic view of information processing. ICS attempts to incorporate psychological approach, representational approach. Next is hierarchical task analysis. Hierarchical task analysis developed by John Anand in 1967 and forward for research. Already in my first video, task analysis, we see what is task analysis, but in short, task analysis investigation how a task is proficient, including a detailed description of both manual mental activities, that frequency, task allocation, task complexity, environmental, task allocation, and any other unique factor involved in required one. More people perform given assignment work. So this is the cognitive model, and for a different HCI models I will see in this video. Thank you for watching and listening.